Okay, since we've gone over so many infinite series tests recently, those would be the alternating series test, the limit comparison, the root, the ratio, the geometric series, the nth term, and the direct comparison test. I figure since we've gone over so many recently, then we might as well do a few practice problems involving infinite series. So this video is going to consist of 4 practice problems that we're going to go over, and they're going to consist of the infinite series tests I just listed. So fair warning, the infinite series that we're going to go over today are pretty simple. In a future video, I will make more complex ones, but I just didn't really have much time. So this is the first infinite series. We're going to try to find the convergence of the infinite series from n equals 1 to infinity of 8 to the power of n over 7 to the power of n plus 1. Now we can rewrite this because the denominator, in fact, can be rewritten as 7 to the power of n times 7. So this whole infinite series is actually equal to 1/7 times 8 over 7 to the power of n, because we're just factoring that exponent. Now, the setup looks similar to the one of the conditions for the geometric series tests, in the sense that we have a to the power of a times r to the power of n. And of course, our setup looks similar. However, for the geometric series test to converge, or for an infinite series to converge using the geometric series test, we have to find our value r, the absolute value, in fact, and that is equal to the base of the exponent, which is going to be 8/7. Now, unfortunately, 8/7 is greater than 1, so this infinite series here will diverge, and I'll state that right here. So the infinite series from n equals 1 to infinity of 8 to the power of n over 7 to the power of n plus 1 diverges by the geometric series test. Okay, so this is our second practice problem and our second infinite series test. We can't really rewrite this or simplify it in any way that's meaningful or useful. But if you'll notice, this looks similar to the setup needed for the, what's that one series test called? P series test, yes. So P series is, of course, an infinite series with whatever the inside is called. I cannot remember. Let's just call that the equation. It's the equation of 1 over n to the power of p. Now, p must be greater than 1. You'll notice that over here, in place of p, we have e. And since e is greater than 1, we can say that this series over here converges. So I'll write that right now. The infinite series from n equals 1 to infinity of 1 over n to the power of e converges by P series. Okay, so you notice this question is a bit more complex. I figured I might as well mix it up a little bit. I got this question. I did not make this myself. I got it from my previous calculus teacher. So thank you, Ms. Tan, even though I did not ask for permission. Anyways, let's get into this one. And my technique for solving complex infinite series is just to employ the ratio test. It's best to look for patterns, but this is just frankly what I do. So the ratio test, if you don't know, states that the limit as n approaches infinity over the original expression here, except in place of n you have n plus 1 over the initial expression. If the absolute value of that happens to be less than 1, then it converges. If it's greater than 1, if it diverges. If it's equal to 1, it's inconclusive. So we might as well write that the limit as n approaches infinity of n plus 1 times 7 to the power of n plus 1. And of course, we can just rewrite this term over here. So we actually end up with 7 to the power of n times 7 over n plus 1 factorial. Now, n plus 1 factorial is actually equal to n plus 1 times n factorial. I'm just doing this because it's easier to simplify later. This is because n plus 1 factorial is equal to n plus 1 times n minus 1 times n minus 2. However, this function right here is actually equal to n factorial. So n plus 1 factorial is equal to n plus 1 times n factorial. And as I just said, it's simply easier to simplify later. So that's the reason we're doing it. Times the reciprocal of the original expression, which is going to be n factorial over n times 7 to the power of n. And you'll probably already notice that we can cross out a few of these terms. The first one being n plus 1, second being 7 to the power of n, and the last being n factorial. So now we end up with, we might as well pull this 7 out of the limit, 7 to the power of, 7 times the limit as n approaches infinity of the absolute value of 1 over n, because that's the only term we have left at this point. Now, this has to be less than 1 for it to converge. Is this less than 1? Well, the limit as n approaches infinity of the absolute value of 1 over n is actually equal to 1 over infinity, which is equal to 0. So we end up with 7 times 0, which is 0, and 0 happens to be less than 1. So, in conclusion, or therefore, the infinite series as n equals 1 to infinity of n to the power of 7n over n factorial converges by the ratio test. Okay, this is our last and final practice problem for today. We're told to find the conversion state of n equals 2 to infinity of 2n over n minus 1. Now, we're going to employ the nth term test for this. It could have perhaps been the first infinite series test you learned, and so you may be rusty, even though it's so simple. That's why we're going to go over it. We have to find whether or not the limit as n approaches infinity of the expression here, 2n over n minus 1, is less than or is greater than 0. If it is, it converges. Sorry, if it is, it diverges. And this question is incredibly simple. You'll notice that the limit as n approaches infinity is of 2n over n minus 1 is just 2. And this is because we try to find the variable with the highest degree or greatest exponent. Now, in that case, these are both equal. And so what we do then is we just divide the coefficients, and that happens to be equal to 2. So 2 is greater than 0, and therefore the infinite series as n equals 2 to infinity of 2n over n minus 1 diverges by the nth term test. Now, that's it for today's video. If you have any suggestions, leave them in the comments. I will make a future video going over more complex infinite series tests if you'd like. And thank you.